Hello and welcome. My name is Mohammed Hassan Bannour and I'm going to be your instructor for this video. Let's begin. As for the packages, we are going to use two packages in this lesson. We can load these packages by running this code. As for the data, we are going to use tuberculosis treatment outcomes data from Benin. Import this data. All we have to do is run this code and we can see that this data basically contain period, the hospital, the outcome, the diagnosis type, and the number of cases. Our data is aggregated on multiple levels. We are going to identify these levels so that it's easy for you to follow along when we code. The first level of aggregation is the time level, and this time level is denoted by the two columns, period and period date. The second layer of aggregation is the health facility identifier, or basically the hospital, and in our case we have 6 hospitals in our data. The third layer in our data is the aggregation by treatment outcome in the outcome variable, and in this column we have 5 outcomes: the completed, the cured, the died, the failed, and the unevaluated outcomes. Additionally, the fourth layer of aggregation is diagnosis categorization, which is basically the diagnosis type. And finally, we have the case counts depicted in the cases column, which basically a case that quantifies the number of cases for each observed combination of our columns. Basically, we will use bar charts or grouped bar charts to identify and compare groups together over time or over subcategories. Let's start by bar charts. Bar charts are ideal for comparing data sets. Let's leverage these bar charts and start a plot that allows us to visualize the number of cases per treatment outcomes in our data set. The first thing that we have to do is identify the assets in ggplot2, and this is by specifying the x and the y axis. In our case, we would like to have in the x axis the outcome, since it's the categorical variable in our case. So x equal outcome, and in the y-axis we would like to see the number of cases that's depicted in the cases column in our data. So I took the liberty to put the name of the plot. So once I run this plot, I will have this, a bar plot that tells us how many patient per outcome for all of the periods in our data. We are going to change the x-axis variable, and in our case we are going to use the colon hospital as a next axis. So the idea is that we want to see the case counts for each hospital. So we are going to use the same structure of the code as previously, but instead we are going to specify in the x-axis hospital, and in the y-axis we will map the number of cases by the cases column. So once I run this code, I will have this plot. As you can see, this plot conveys the information in the most organic way. It's clear and simple, but we can improve it. Actually, we can flip the columns, the axis, so that we have hospitals on the y-axis and the cases on the x-axis. To do that, we are going to utilize code flip function. This is the same code that we've done earlier. All we have to do is we add the code flip function, and always don't forget the plus so that it's related to the previous code. Now that I have that, if I run the code, I will have exactly what I described for you. The coordinates are flipped, and now I have the hospital names on the y-axis, and the value of cases for each hospital is on the x-axis, and this improves relatively the readability of the plot. Next, we will learn more about the stacked bar charts, which basically allows us to introduce another second categorical variable in our plot, which allows us to have deeper insights. So since we have in the previous code, we have x in the x mapped to hospital and y mapped to cases, now we have to add another categorical variable, another dimension to visualize. And in our case in here, we are going to use the outcome column as a third variable. So what we can do is say fill, that allows us to specify the color that fills these bins, and we will say that fill these columns based on the variable outcome, and once we run this code we end up with this bar plot. And in here you can see easily that for each bar we have specific groups that we can visualize and compare across all the hospitals. So we've seen and discovered the normal bar charts, the stacked bar charts. Now it's time to see what the grouped bar charts are capable of. So if I keep this and run this code, we will generate the same plot than previously. The only difference here is that we would like to see the outcome counts of each hospital side by side. The way to do it is to come here in geom_call and say position equal dodge. And once we have that and run the code, we'll end up with a plot that looks like this. This is simply amazing. 2 words, that's all you have to write, and you have a completely different kind of plot. However, there is one limitation to this technique, and that it's not ideal when we have multiple outcomes that we want to visualize grouped together side by side. So this might work if you have, for example, 2 or 3 categories, but in our case we have basically 6 categories, secondary categories that we want to visualize for each hospital, and that's a lot. This is not the proper technique for this. However, we can try this with a smaller number of categories. So we can, for example, say fill equals diagnosis type, since we have only 2 diagnosis types. So this might make sense. So let's see. Oh, look at that. This is way better. Now, please take a moment and try to answer these 2 questions. One way to enhance our plots is to use and add error bars to our columns and our plots. Adding those error bars allows us to illustrate the reliability of these estimates and the visualization that we're doing. And this basically is done using the function geom error bars from ggplot2. Let's see how this is done. The first thing that we need to do is to summarize our data. Since we have different levels of aggregation and we're going to add these error bars, it's very important that we understand exactly what we are visualizing. So let's summarize our data by period and diagnosis type. Eventually we would like to see the number of cases for each diagnosis type for each period. Simply we're going to change this by specifying that we want to use period date and diagnosis type to group our data. Then we would like to do the following. In summarize, we will summarize our data so that the total cases is the sum of all of the cases grouped by period and diagnosis type. So we say cases, sum of cases, and we do not forget the NA RM equals true, so that we ignore the missing values if any exist. Also for the error, we will calculate the standard deviation of all the cases, specifying that NA.RM equals true. If I run this code, I will end up with the data that looks like this. The data contains the period date, which is basically the specific quarter that we recorded that specific data, the diagnosis type, bacteriological or clinical, the total case for each, and the error for each. Now that we have that, we can start building our plot. So for the x-axis, we want to see the period date. In the y-axis, we would like to see the total cases. And in the fill axis, we would like to see the diagnosis type. So once we have that, we say geom and position is dodge, so that we see the bars stacked and grouped together side by side. And then for the geom error bar, we have to specify the y min and y max arguments. For the y min, say total cases, the minimum is the error, so subtract that, and the opposite for the y max. So we say total cases, that's our point of reference, and then the maximum is that point of reference plus the error. Once we have that and position equal dodge, all good, We run this and we end up with this plot. So we can see the errors, we can see the height of each bar plot, but also we can see the different diagnosis type for each period of time, and we can compare across 3 dimensions basically. Now, let's explore how composition illustrates the contributions of individual parts to a whole. Basically, we are going to use the dedicated composition chart types that better represent these relationships, mainly the pie chart, the donut chart, and the stacked bar chart. So let's start by the stacked bar chart. So the way to do that is to keep the fill outcome in here. So let's start by seeing the usual suspect, the usual bar plot, nothing fancy in here. And what we want to have is a normalized bar chart. And the way to do it is to specify one simple argument in gmcall, and that is position equals fill. And once we run this code, we'll have a complete different plot. And this is a normalized plot. And what we can see is the proportion for each of the outcomes per each hospital instead of the case count. This allows us to understand the composition of our data and how all the subgroups contribute to the entire story. Now, since we know how to do the percentage stacked bar plot, it's time to move to the circular plots, the pie and donut charts. As usual, before we start, let's start by summarizing our data just to be sure about what we are visualizing and make sure that we're not making any kind of mistakes. And the way to do it is, as usual, by taking the group by and specifying what variable we want to group by our data with this time. And in our case here, we would like to group by outcome. Yes. And then we will summarize the cases for each of the outcomes. So we'll say cases in here. And don't forget to put the na.aram equals true arguments. So once I run this code, I will end up with a data that looks like this, with outcome and total cases, colons. Very clear, very simple, and that's what we need for our circular charts. The main idea of a circular chart is that it's basically a rounded version of a single 100% stacked bar. So basically we take that 100% stacked bar and round it together. And the way to do it is we will take our aggregated or summarized data. We will specify an arbitrary x because we will only need one bar, so we'll say 4, for example. And for the y, we will say, give me these total cases. And in the fill argument, we will say outcome. Now that we have these, we can run and we will have this single bar chart. The idea of a pie chart is basically taking that single stacked bar chart and turn it into a circle. And that's basically changing the coordinate system of that bar chart. The way to do it is to specify coord, not Cartesian, not equal, coord polar. And we will specify theta equals y. So basically we will take the total cases from here and assign it to theta, which is the angle argument for the coord polar, the polar coordinate system. So let me run the code here. So as you can see, with one single line, we have this pie chart. To wrap up our lesson, we leverage ggplot2 in this lesson to differentiate between how to compare subgroups and how to understand the composition of our data through these subgroups. We were able to create different types of bar charts, namely the normal bar chart, the stacked, the grouped, and the normalized bar charts. We also transitioned to circular plots using pie charts. This is the end of the ride for this lesson. Thank you so much again, and see you in the next lesson.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.